I'm Nisim Perets. I'm the CEO and co-founder of Itay&Beyond. I have a PhD in neuroscience, and today I'm going to show you a real lab-grown brain tissues playing a computer game in the lab. So what you're going to see here is the lab that we're going to take you for a small tour. The lab-grown brain tissues start with a urine sample that we take from patient. From a urine sample, we extract cells. The cells, we reprogram them to become stem cells. From them, brain organoids, and then using multi-electrode array, we are connecting them to a computer.
Wow, let's see it. Can't wait.
So first of all, I'm going to share with you the labs here. So everything that we talked in the podcast, by the way, it's happening in here. And you're going to see Dr. Nir Weisskopf. Dr. Nir Weisskopf is the VP R&D of Itay&Beyond, and he's going to show you how it works. I would start from the beginning, from the tissue culture. So first of all, we are sitting in a beautiful facilities named Biohouse. I would just say that in Israel, it is very the biotech industry is very developed, and Biohouse is some kind of facility that helps companies, rent a place and get an access to this high-end equipment here. This is the real science going on in here. And what you're going to see right now is the tissue culture room, which is exactly the place when we take urine from patients with autism or from control patients or epilepsy, and turn them into a live-grown brain tissue that can encode information and be used for drug screening. So, wow. Nir, the stage is yours.
Ooh, the incubator.
Yeah, nice. So this is an cell incubator, and what Nir is going to show you is basically the dish of 24 wells, 26 wells, with each well containing the brain, some of the brain tissue.
So this is a dish with a lot of brain organoids from a human patient. Let's try to have a look in the microscope.
In the microscope. So those, we can see them when they grow bigger. They can be seen without the microscope. But what Nir is going to show you here, they are still small. They are still baby tissues. And after that, we're going to see a bigger tissues in the lab. Maybe I will try to do. I don't know if you could see it through the microscope, because it's try to make one. Yeah. So this is the very rare tool. Let's see if you see something in the.
Oh, there was something.
Yeah. You see the black. The black is the beginning of the tissue. The black in the lid. Just 1 second. I'll try again. Here, this black is the tissue. Okay. In the microscope. Yeah. So it's a clump of cells that the light don't go through, so it looks very, very dark. And then we put them on a multi-electrode array inside of this incubator that Nir will show you.
Mm-hmm.
And after that, we teach them to play computer games.
Crazy.
So this is the multi-electrode array. What you're going to see here. You have one. It looks like this, the multi-electrode array. I'm not sure. We're not sure that the organoid is growing. No, here doesn't have a brain organoid, but it's gonna bring one with one. But this thing contains 64 electrodes that each one of them can record and stimulate the brain organoid, and then basically generates a closed loop from the computer to the brain organoids. We will take them to the computer.
Okay,
yeah.
Let's show them how it looks on there.
לא, ניקח את זה ישר לשם. כן, כן, ניקח את זה ישר לשם. We're going to take you to the station where when we have already a lab-grown brain tissues playing a computer game from patients.
That's wild.
Yeah. So what we do here is this is the basically where everything happened. Yeah, and in this machine we put what you see here. Each machine like this is connected to a computer. Okay, and then the stimulation from the brain computer is running here. So what you see right now is a video. It's not live. We just activated the video. Right now at the moment we don't have an active experiments going in the lab, but this is a video of recording of a previous experiment from yesterday. That what we did, you can see here the activity of the lab grown brain tissue. You can see here the responses of the stimulation and recording, and it responds every time that the coin is dropping from the left or from the right. This is an attention task.
יש לזה אורגנוידים.
And over here, you can see a real lab-grown brain tissue in the. Okay, you see it. You see
The white,
I
the
saw
white
it.
tissue.
Wait a second.
אפשר להראות להם, you can put it in a microscope.
Yeah. So, but because of it's a bit difficult, hard to see it. But when we put this on the device here, when we put this on the device here, it's basically connected to a computer, and then we can activate a stimulation of. And Nir is going to show you here, maybe under the microscope, how it connected to the computer, how it can basically attached to the multi-electrode array. It's it's a 64 array, and each electrode can record and stimulate, and then you can get it in here. So Nir is preparing the microscope with the visualization to show you. Oh yeah, this looks good. Yeah. So you see in here. Wait a second. Okay, so this is what you see here.
Yeah.
Oh, sorry.
It's okay. What you see here is the lab-grown brain tissue. This is not a high-resolution microscope, so you can see it also in the eyes. It's just a camera for you to see better. And each line here is an electrode that it's connected to the end of the organoid. So it basically sits on it like this. And then when we put in this blue machine, it connected to the computer and stimulates and recording the activity in live. Then we film it, we record the session, and we analyze the session in also in AI and machine learning, basically that can provide us with new insights. When we want to test different drugs and compounds, we just put them, drop them on the brain organoids itself. We also have another system, which is here. This is our advanced system. In this system, what you see, it's now not activating because we don't have any experiment going on, but the brain organoids sit inside of a machine like this, inside of the incubator. And what it basically provides us is the ability to record for, let's say, a week of neuronal activity of the brain organoids to teach it a few, I would say, stimulation, like a memory test, attention test, as you saw here, a maze, something like this. And then it's like a matrix. It learns a few different, it trains on few different stimulations, and then we get the score of all of them. It's like having a behavioral test for, let's say, a child with autism that includes attention test, memory test, and then to get a combined score of all of them. So this is what we do here. Thank
you so much for the amazing lab tour. That was really cool to see.
Thank you very much. Thank you. I hope you enjoyed.
Yeah, bye-bye. Keep up the great work. Bye-bye.
Thanks. Bye-bye.